Okay, so over the past couple days, we've just got done covering the data collection information. We've taken data and we put it into a table. We've collected data and put it into a graph. We've made observations about what's happening based on the data. So now our next step in our progression dealing with data is to come up with scatter plots. We're going to talk about scatter plots. All right. Also, with scatter plots is lines of best fit. So what I'm going to do is if you printed off the notes from online, we're going to go directly through these notes from online, and we're going to go ahead and fill in the answer blanks, and then we'll sum it up at the very end. So this is just something I'm not going to give you in class. You need to go ahead and print these out on your own. If you don't get these by the time you watch this video, come see me. I can get you a copy. But for now, we're just going to go ahead and go through the notes on our own. If you've printed them out, just follow along as we go. All right. So scatter plots and lines of best fit. Real world data doesn't always fit into a nice straight line. Sometimes when we take data, like you guys saw over the past couple days when we're doing, penny can and we're doing push-ups and we're doing all this other data collecting that we have done, even in my kitchen from the last time that we saw each other on the video, I did the data collection of the food and the grams and calories. It doesn't always fit into a nice, perfect straight line. It's not always a linear function. When it's a straight line like that, we call it a linear function. In this case, data that we collect very often in the real world is not linear, okay? So what happens is we have to use a scatter plot. So scatter plots are often used to model this data so as to observe patterns and trends. So we use the scatter plots to observe patterns and trends, and actually we can use them to make predictions as well. So let's go ahead and jump right in here. It says example 1, using the data in the table, sketch a graph of a local football, sketch a graph. And then it says a local football team has gained the following yardage in the first 7 games, okay? So I'm going to erase this scatter plot and I'm going to move this up so we can see it a little bit better. Okay? So here's our data that we've collected, or some statistician collect this data and said, okay, in the first game they gained 348 yards, the second game 350 yards, the third game 300 yards, the fourth game 295, fifth game 280, sixth game 250, seventh game 225. You can kind of see a trend as you look here at the table. With the exception of the first game, all the games start to go down. Okay, that's not really a typical idea of a season. When you talk about football, if you know anything about football, you know that sometimes you play a bad team and the yards that you gain, you're going to have a lot of yards that you gain. Sometimes you play a bad team. If you play that bad team, you gain that lot of yards. The next week, you'll turn around and play maybe the best team in the league, and you won't gain as many yards. And you could play a good team, then a bad team, and then another bad team, and then another bad team, and then you play a couple good teams. It doesn't really go. Your schedule doesn't get harder as the season goes, not till playoffs at least. So this information can really be skewed and really be out there. Some days you have really good games where you have a lot of yards. Some days you have really bad games, you have low yards. But in this case, we're going to draw a scatter plot to see how the data looks. So when we take this, just like we did earlier in the data collection, when we take this table, we're going to put it into a chart, create an X and Y axis. Okay, your x-axis is always horizontal, your y-axis is always vertical. Okay? And I told you in the data collection activity that usually in your first column you're dealing with your x value. So we're going to put our game down here. Okay, this is the games. Okay? In your second column, like I said before, we're dealing with our yards. Okay, so we're going to put our yards on the y column. Sorry, the second column deals with the y column. So we're going to put our yards on the y-axis. And then we need to go ahead and go through here and make a scale. Okay? And so I'm going to start here. I'm going to put 0. The first one, the x-axis, so the x column is going to be easy because it's just 1, 2, 3, 4, 5, 6, 7, a constant increase. So I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I put more than I needed there, and we'll talk about why that is in a minute, because we use scatter plots. If you saw earlier, we can make observations or we can make predictions. So even though we haven't played 8, 9, and 10 games yet, I'm going to put those on there because eventually they will be playing that many games. Okay? And then on the y-axis, we have anywhere from the low point is 225 to the high point of 350. So we need to make a scale. Now I'm going to make this little break right here in our axis. What that break shows you, it's a little squiggly line. What that break says, I'm skipping a whole bunch of numbers, but then I'm going to start up with my normal scale. So I'm going to do a scale of about 25. So I'm going to skip my numbers here, and I'm going to start with 200, and then I'm going to go to 225, and then I'm going to go to 250, and then I'm going to go to 275, and then 300, and then 325, 350, and 375. I'm just going to stop there because I know no game is over 375. Now again, that break is important because from 0 to 200, that's a 200-yard increase, but then we pick up a scale where it's only 25 yards. That break says, hey, we're not going to put all the data before that because it's not really relevant, so we're just going to start with 200, even though it's a big jump. We're going to start with 200. That's what that break is for, okay? Now, we're going to go ahead and plot the games. So, game 1, they gained about 348 yards. So I'm going to go up here, just under 350, and I'm going to plot a point. Game 2 is 350 yards. So I can go up to 350. Just a little tiny increase, a 2-yard increase from game 1. Game 3, we dropped all the way down to 300. Okay? Game 4, we dropped to 295, just a little bit under 300. Game 5, we dropped down to 280, which we're going to put that right above the 275 tick mark. Game 6, we're at 250. You can see that this team is not getting better. As the season goes on, they're getting worse. And game 7, we're down to 225. So if you look here closely, you can see that it's not a perfectly straight line. That means it's not a linear equation. This is not a linear function. This is a scatter plot because the data is off a little bit. It's not perfect. All right, so now we've looked at our yards and our table. We've collected our data. We've looked at that information. We've plotted it on a plot like you've been doing for the past few days. Now, what are we going to do with that data? Okay, so I'm going to move the notes up just a little bit. Hopefully you can see that right here. But down here it says to make a prediction or to make predictions based on this data, a line of best fit must be found. So this word right here is line of best fit. Now sometimes you might hear this as best fit line. I'll refer to it as best fit line. Sometimes you might hear it as called a trend line. All those things mean the same thing. Basically, a line of best fit is a line that kind of represents the data so that we can use it to help us figure out some more information. So how do we draw one? Okay. Well, to draw one, you find a few points that are more or less in a line, 2 to 3 points. So if we're looking at our data right here, we have 3 points that are kind of in a line. Here's another point that's up here in a line. So we do have some information in a line. So here we found the points that are in a line. Then it says draw the line. So once you've found those points, go ahead and draw your best fit line. So I got these lines, these dots in a line. So now I'm going to draw my best fit line. And you really want to draw it all the way through your graph if you have a larger graph, okay? So just draw it all the way through. And now if you notice, I have 4 dots that are touching that line, okay? So the next step says the remaining points should cluster around the line. So I should have points that cluster around the line. Now these points do, they cluster around the line. They're pretty close to the line. They're not on the line, but they're pretty close, okay? The remaining points should be evenly distributed above and below the line. Now, sometimes that's going to be hard. What it's saying is some of my dots should be above the line, which I could have maybe done that, but it's really hard to say. Sometimes, as long as they're very close, it's going to be okay. But you should shoot for a couple of dots above and a couple of dots below the line, okay, if you can do that. But it looked like our best data kept all the dots below, just barely below, okay? And again, a part of that reason for that is because this information is really kind of close to being linear, but it's just not. Okay, so we've drawn our best fit line. So I'm just going to go ahead, or line of best fit. I'm just going to label this LBOF, LOBF, okay, line of best fit, all right? So what are we going to do with this line of best fit? Let's move up and find out. Okay, so it tells us to draw a line of best fit for the data above, which we did, okay? And now it says use that line of best fit to predict how many yards the football team will gain in game 9. Like I said earlier, we drew game 9 and 10 on there because we knew that they were going to play that game. So what we need to do now is predict how many yards do we think the team will gain in game 9. So what we do is come down here on our games axis, okay, and we look at game 9. Here's game 9 right there. In order to predict, okay, to predict something that hasn't happened is to look at that best fit line or that trend line that we created and go ahead and go from game 9 and work our way up. Okay, it's going to be about right there on the line, okay? Now, if I want to know exactly how many yards or somewhere what I think the yardage is going to be, I'm going to go from that dot that I just created across to my y-axis. You're going to kind of have a rectangle if you connect this. It's a little rectangular box right here, okay? And this will kind of give you my data. It's somewhere in between 200 and 225 yards. I would guess about 210 to 212 yards. So in game 9, they should gain about 200 and, I'm going to go 212. I'm going to be out there and just say 212 yards, okay? Now, again, could they have a great game and gain 400 yards? Absolutely. We don't know. This is a prediction. We can't predict things all the time to be perfect. But based on what's happening here, okay, we can see that there's a great chance that it's probably going to be anywhere between 200 and 225 yards because they're not doing better. They're actually getting worse. Okay? So that's what we use our line of best fit for. Okay? All right. Let's go ahead and finish up these notes. Now, based on the trend of your line, and I'm going to erase this, we're done with this. Hopefully our Midlothian football team will be better than that. They won't get worse, they'll get better throughout the season. I know Coach Wigington and those guys will get it done, okay? Now, based on the trend of your line, okay, or the line of best fit, a scatter plot can have 3 types of correlations, okay? We're talking about 3 types of correlations. There's positive, there's negative, and there's no correlation, okay? So let's talk about each one of those. These are actually very simple if you think about them in terms of what they look like visually. Okay? The first one, all of our dots are going up. When something goes up, if you're going up or if you're in an up mood, you would be considered to be positive. So all my dots are going upward. And that's going from left to right. All my dots are going up. So we would call this a positive correlation. Now, just because the dots are going up, that's not our definition of positive correlation. I don't want you guys to say, oh, well, yeah, they're going up, so it's positive. Yes, that's a way to look at it, and that's a way to find it and identify a positive correlation, but we need to be more educated. Unfortunately, you know, we are in math, and we're trying to learn the definition of things, and we need to know exactly what it's talking about. So let's look at it more closely. Let's get a better mathematical definition. What's happening here? Now, here we have an x, and we have a y-axis. Okay? Whoops, I put y. That's an x. Okay? Now, what I'm going to do is I'm going to take that data, and I'm just going to turn this into a big x and y-axis. Not a big deal. Just to kind of visualize, help you visualize it. This is x, and this is y. Now, if we're talking about left to right, anytime you go from left to right on the x-axis, you are increasing. So as I increase my x-axis, every time I go from left to right, which is what we're talking about, you're going to increase your x-axis. So if I increase my x-axis, okay, what's happening on my y-axis? Where are the dots going? Because everywhere I go this way on the x-axis, where are the dots going? Are they going down? Are they going up? Are they going all over the place? Well, you can see the dots are going upward, right? So as I increase my x-axis, my y-axis is also increasing. So it's an increase in x and an increase in y. So you would write as x increases, y also increases. Okay, so again, as x increases, y increases. Now, let's look at the next one. The next one, we're talking about dots that are going in the downward direction. Again, if you're down or you're in a down mood, you could probably be somebody that could be considered negative. So if it's going down, it's easy to spot and identify visually because all the dots are going down. We say that is a negative correlation. And again, very much like I said earlier, we don't want to just say, oh, it's going down, so that's a negative correlation. We also need to know exactly what's happening on our x and y axis. Now, be careful here. A lot of students, the misconception is, oh, well, positive, x increases, y increases. That means negative is the complete opposite, so that means x decreases, y decreases. But remember, that's not the case, because remember here, if I take this quadrant, these four quadrants, turn into one big giant x and y axis, remember what's happening. We're always talking about going from left to right. Always talking about going from left to right. That means x is always increasing. So as x increases. So even though that positive and negative are opposites of each other, in this case we're still talking about x increasing because we're always talking about going from left to right. So as x increases, because this is going to increase, like the football games, 1, 2, 3, 4, numbers getting bigger. What's happening now to my y? Is it going down? Is it going up? Or is it all over the place? Well, it's clearly, you can see the dots are going downward. Okay? So my y-axis is decreasing now. So as my x-axis increases, my y-axis decreases. So down here we're writing as x increases, y decreases. Okay? Pretty simple. Again, it's going in the downward direction. We know it's negative. That's pretty common. Okay? All right. And finally, let's look at the last one. Since I've created an x and y axis on all these, I'm going to do the same thing here. Just to kind of visualize this. You don't have to do this on your paper. If you want to, that's fine. I'm just kind of helping you visualize this. Okay? Now, again, what's happening here? Does the dots go up? Do the dots go down? Do the dots go anywhere that you can tell? No, they're all over the place. The dots are everywhere here. They're scattered. You can't tell if they're going up. You can't tell if they're going down. You can't tell anything. So in a case like this where you can't clearly see a positive or a negative trend, you would call this no correlation. Or none. Sometimes it's just none, no correlation, none. Okay? Now, again, we're talking about left and right, so as x increases, what's happening to y? Well, you can't tell. Can I draw a line going down saying y is decreasing? No. Can I draw a line going up saying y is increasing? No, you cannot. So as x increases, we don't know what's happening to y. It's everywhere. So you would say there is no relationship between x and y. Okay? No correlation. You got to be careful. Sometimes dots are spread out a lot and people think it's no correlation, but there really is a trend. You just have to kind of look for it. But in this case, it's clear. It looks like kind of like a shotgun. You blew a shotgun and there's just there's just pellets everywhere. Okay? All right, so let's put this into action. Let's go ahead and erase this. All right. So example 2 says the following scatter plot shows the cost of a phone call overseas. And when you call somebody overseas, you're going to have to pay by the minute. It's not like your cell phone where you can, call and talk to anybody forever. You actually have to pay for those phone calls. But it's the cost of a phone call overseas in relation to the number of minutes of the phone call. So the cost is over here because that's dependent. Y is dependent, which we're going to talk about later. The cost depends on how many minutes that you spend. Your x-axis always represents the independent. And again, we'll talk about that later. So here's your cost, 2, 4, 6, 8, 10, 12, 14, 16, $18. And here is your 10, 20, 30, 40, 50, 60, 70, 80, 90 minutes. Okay? So if you're talking to somebody overseas for a long time. And this is actually good information if you have friends that live overseas. I have friends that are missionaries. So, it's good to know how much it's going to cost me if I call them. Okay? All right, so let's look at our questions. All right. The first one says, what type of correlation, if any, exists? Okay? So can we look at our dots and can we tell what is happening across my x-axis? What is happening? Of course, we're going from left to right. So as x increases, so we're saying x is increasing. Okay? What is y doing? X is increasing left to right. What's happening to y? Is it going up, down, or all around? Well, it's clearly y is increasing. So x is increasing, y is increasing, and so since x increases and y increases, we remember that to be a positive correlation. And again, the shortcut is, are the dots going up? Absolutely, the dots are going up, so we call this a positive correlation. All right. Now, number 2 says draw a best fit line, or a line of best fit, sorry. Okay, so let's go ahead, get our ruler out, we'll draw the line of best fit. Again, we want to find a couple dots that are in a row. Okay. We got a couple dots that are in a row, and then we draw our line through that. All right. So there's our line of best fit. Again, I drew it all the way through because as you saw earlier in our games, our football games that we were talking about, we needed to make a prediction. So I went ahead and drew it further, okay? I'm actually going to extend it all the way until the board runs out. Not very straight, but until the board runs out. So there's my best fit line. I've got it through a couple of dots, and I have a couple of dots on top, one dot on top, one dot on bottom. Okay, it's pretty accurate. Now it says use a line of best fit to predict the cost of a phone call lasting 60 minutes. So I need to go over here to 60 minutes, and I want to make a prediction. So I need to go to 60. It's giving me the 60 minutes. It tells me 60 minutes. So I need to go over here and use 60 minutes. And then, again, from 60 minutes, I'm going to draw my line up. I'm going to hit my graph. When I hit my graph, I'm going to immediately take a left. I got to take a left so that I can go to my y-axis. It's kind of up there, so it's hard to see. Okay, so once I go up, hit my graph, I take a left. Now, based on that, okay, based on the rectangle I just created, my up and over, it looks like a 60-minute phone call is going to be somewhere in this area. Well, if we're going up by twos, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18. This should be about $20. So the cost of a call lasting 60 minutes will probably cost about $20. Okay? Now, here's where it gets a little interesting. Okay? It says number 4, use the line of best fit to predict the number of minutes that a $12 phone call lasted. Earlier, when we did the games played, we stayed on the x-axis, drew our line up to the graph, and then we took a left and went to the y-axis. This time, they're giving us information about the cost, the dependent value, $12. So we're starting on our y-axis here. Now we're starting on our y-axis. We're doing exactly the same thing. We're going to take our y-axis, go to 12, draw our line. Once we hit our line now, we're going to go straight down. We're going to drop. Okay? And we find out how much it costs to make a 12-minute phone call. And it's somewhere in between 30 and 40, closer to that 30 side, so I'm going to guesstimate about $32 would be my guess. Okay? And it's just a guess, okay? It's not accurate. You're just predicting because nobody's made that phone call based on the data. We just want to know, just in case we wanted to spend $12, how much time would it take? And so it looks like, or how much money would it cost? It looks like it'd be about $32. All right, and that concludes our notes. So let's sum it up, okay? So basically, just like we've been doing for the last few days, we're going to collect some data, put it in a table. Once we got it in a table, we're going to figure out what's our x and y axis. First column is usually the x-axis. Second column is usually the y-axis. Plot that data. When you plot that data now, you have now created a scatter plot. It's not just a graph, now it's a scatter plot. Chances are the information is not going to be linear. It's not going to be a perfectly straight line. So you have now a scatter plot. Okay, what do we do with our scatter plot? Well, with our scatter plot, we can make observations and we can make predictions. We use a line of best fit in order to make predictions. We draw that line that's as close to the data as possible, and so we can see where we can make predictions on other information that we don't already know yet. So we use that line of best fit data to make those predictions. Now, why is this important to you? Because I know that a lot of times we sit at home or we sit in the math class and we say, you know what, I'll never use a scatter plot. I'll never use this data. But the reality is on this one, I can confidently tell you that you will use scatter plots, you can use scatter plots in the future. For example, businesses will do scatter plots all the time to see how products are selling. Is their product selling good? Is it time to make a new product? Is it time to change the product because the product has a negative correlation or a negative trend? People aren't buying that product. We've got to make a change now. If I'm a general manager for the Texas Rangers, for example, the general manager is the one who re-signs or signs contracts for those athletes. If I'm the general manager of the Texas Rangers, I can use data to see how is Michael Young been playing over the past 10 years. Let me see his statistics. If his statistics are going down and it has a negative trend and it's time for him to sign a new contract, do I want to sign him based on his trend? I can see what he's probably going to do for our baseball team over the next couple of years. General managers do this all the time. You can use the scatter plot data and put this in there and say, hey, this is a visual representation of what you're doing, and to make that point even more and say, hey, we're not going to pay you all this money because you're not doing well. You're getting worse. Just like our football team in our first example, we were getting worse. So scatter plots is good information. Lines of best fit will help you predict that information. It is something that is going to be useful for you in the future when you are doing some data collecting. And pretty much most jobs have some type of data collecting. You may not do it all, but somebody will, and it might be you.